Machine learning utilizes a wide range of algorithms and models, each suited to a specific problem. These algorithms allow machines to learn from data and make predictions. We have already mentioned linear regression, which models the relationship between input features and a continuous output. It's fundamental for predictive modeling. You may even have done simple versions of it by hand in math lessons. In statistics, linear regression is used to understand relationships between variables and to make inferences. In machine learning, the focus is on using this technique to make predictions or to generalize to new data. Logistic regression is similar, but instead separates data into groups or classes based on probability. For example, we placed our animals in cat or not cat classes earlier. Logistic regression can be used for binary classification, in which data is split into just two classes. Our example uses the hours studied by those who've passed an exam, in red, and those who failed it, in blue, to give a probability of whether someone is likely to pass an exam based on the hours they've studied. Decision trees split data into branches to arrive at decisions based on input values. Each node in the tree represents a decision point based on an attribute. Each branch out of this node represents the outcome of that decision. The process continues until a final decision is reached at the leaf node. This represents a class label or a continuous value. The k-nearest neighbors or KNN supervised learning algorithm classifies data points according to their proximity to other points. A test data point is assigned to a class by looking at its closest neighbors and taking a majority vote among them. K-nearest neighbors is effective for tasks such as pattern recognition and recommendation systems. In our diagram, the algorithm needs to categorize a new data point, shown in red, into one of two classes. Suppose these represent social media posts that have been analyzed to measure their political stance. Class A are posts by the far left, Class B by the far right. The algorithm compares the new data point to the existing ones and finds those closest. If our algorithm is looking at the three nearest neighbors of the new data point, that is, k equals 3, it will be categorized as Class B on a majority vote. These models are tuned for accuracy by altering the value of k. In this instance, increasing the value of k to 5 produces a different outcome. K-means clustering is an unsupervised learning algorithm that groups data points into clusters according to their similarities. The algorithm repeatedly assigns data points to different clusters and recalculates the center points of the clusters using the mean distances therein, refining the cluster layout until further assignments no longer change matters. It's widely used for market segmentation and image compression. Neural networks form the foundation of deep learning. Individual artificial neurons or nodes receive inputs, apply varying weights through one or more layers, and output the result by means of an activation function. Different types of neural networks perform different tasks. For example, convolutional neural networks specialize in image recognition, while recurrent neural networks are designed for tasks such as language modeling and time series analysis. Transformers, a recent advance, excel in natural language processing. Natural languages are those used for human communication, as opposed to non-human or formal languages such as computer programming languages. Transformers use so-called self-attention mechanisms to handle long-distance dependencies in text. That is, they look for many different contexts and meanings across a very large dataset to build a better understanding of a piece of text. You have probably heard of ChatGPT. The GPT stands for Generative pre-trained transformer.